Hi, in this lesson, we'll focus on debugging our physical circuits. Debugging is already a lot of work, but once you add a physical component in addition to our program, there are twice as many places your bug can be hiding. In the last lesson, we discussed the debugging process, where we look for an issue and try to fix it. With the addition of physical components, we actually need to complete this process twice. We start by writing our program and use the circuit simulator to test its functionality. If we notice an issue, we debug our program at this stage. Once our program works as intended on the simulator, we build it out using our physical components. When we run the program on our physical device, a whole new set of issues can arise, so we may need to debug at this point as well. The first debugging process will happen on Tinkercad with the Arduino simulator. The second debugging process will happen using the Arduino IDE and your physical circuit. Debugging physical circuits can get complicated. Let's take a look at a few strategies you can teach your students to have them solve their own problems. First, we want to have students double check all the connections on their breadboard. They should revisit the image or step-by-step directions to make sure connections are where they should be. We then want them to check all the ground and power connections. Are all the wires that are connected to the ground rail correct? What about those connected to the power rail? If possible, it can help with organization if every wire connected to the power rail is red and all wires connected to the ground rail are black. Next, they should check all the connections on the inside of the breadboard, remembering that all ports A through E and F through J in each numbered row are connected. If they have a component plugged into an A through E or F through J port, they should also have a connection in one of the open A through E or F through J points in the same numbered row, because this is the only way the connection will continue. Next, students should check the individual components. Here are some helpful tips to keep in mind. LEDs only work in one direction, and it is very easy to mix up the placement of the long and short legs. A quick fix to test this is to pull the LED out and switch the placement of the legs to see if that fixes the issue. Resistors are very fragile and have long, flexible legs. This can sometimes make it difficult to push the legs fully into the breadboard ports to make a full connection. Pull the resistor out of the port and carefully insert it again, or trim the legs to make it easier to connect to the needed ports. Many sensors have multiple pins that must be connected in a specific way. For example, the center of a potentiometer must be connected to the Arduino signal pin in order to function correctly. Students should double check these pins and their requirements to be sure that they are all connected in the proper place. The serial monitor is also extremely useful when debugging physical circuits. This tool can be used to print the value of different components or sensors at various times throughout the program. For example, if a distance sensor is being used and it is expected to be reading the distance of an object 10 inches away, and it's constantly providing the value of 0 in the serial monitor, this can signal that something is wrong with the sensor, either in its connection, its programming, or the sensor itself. And if all else fails, a good way to check if you have a faulty device is to replace the one you're using with another. In this lesson, you'll explore these strategies to practice debugging sample circuits. Let's go.